This is a little introduction to trends in the periodic table. What you're going to look at in the notes is the trends in the periodic table in 3 different factors: covalent radius of the elements, ionization energy of the elements, and electronegativity of the elements. These are 3 terms you haven't come across before, but like I say, you look at each one in turn and you'll need to make sure you can remember the definition of all 3 once you have studied them. I'm doing an introduction to all 3 because actually the explanation for the trends, the underlying explanation for the trends in these different factors is very similar, and that's what we'll look at in this presentation. So all of the theory in this section relies on you understanding the different factors which control the force of attraction between the nucleus and the outer shell electrons. If you can get the hang of this, then you should be able to answer the explain questions for any different part of this section of the topic. So when we're thinking about the force of attraction between the nucleus and outer shell electrons, there's a few things that we've got to remember and consider. First of all, opposite charges attract. So we have protons in the nucleus and they attract all of the electrons around the nucleus. Protons are positive, electrons are negative, and opposite charges attract. Remember always to be clear that it's the electrons that are attracted to the protons in the nucleus. Second thing is that like charges repel. So electrons are all negative. Negatives do not want to come into contact with other negatives. They repel each other, a bit like the opposite ends of a magnet would repel each other. And the final thing that's worth bearing in mind is that the strength of electrostatic forces decreases the further away charges are from each other. What this effectively means is that because the inner electrons spend more of their time closer to the nucleus, they will experience a stronger attraction to the nucleus than the outer shell electrons. Because the outer shell electrons spend most of their time further away from the nucleus, this decreases the attraction that they experience to the nucleus. When you're answering questions on this, there are 2 key words that you need to talk about. First of all, nuclear charge, and secondly, the shielding or screening effect. We're going to go on and look at each one, but you'll also see how these are used in explanations in your notes. When you're answering questions on this topic, make sure you use these keywords: nuclear charge and shielding or screening effect. The nuclear charge relates to the number of protons in the nucleus, and remember the number of protons is the same as the atomic number. So as we go across a period, so in the diagram you can see the elements in period 2, the atomic number increases, the number of protons increases as we go across the period, and therefore the nuclear charge also increases as we go across a period. The higher the nuclear charge, the greater the attraction between the outer electrons in the nucleus. So the higher the nuclear charge, we've got more positive charges in the nucleus. That exerts a stronger force of attraction on the outer electrons. In effect, you can think of it as pulling the outer electrons in closer, and that's why the size of the atom decreases as we go across a period. This effect is the most important one as long as the outer electrons are in the same energy level. If the outer electrons are in different energy levels, then the shielding effect becomes more important. We'll look at that in the next slide. The shielding effect describes the fact that when we have inner shells of electrons present in an atom, so most atoms have several inner shells and then the outer shell of electron. When we have inner shells, the inner shells partially cancel out the charge of the nucleus and also repel the electrons in the outer shell. So you can think of, this is why it's called the shielding or the screening effect. You can think of the inner electrons as shielding or screening the outer electrons from the nuclear charge. This effect is most important when we're considering atoms with different numbers of energy levels, or even ions with different numbers of energy levels or electron shells. Think about it maybe as going down a group. That's what's shown in the diagram. As we go down a group, even though the nuclear charge gets higher, this is outweighed by the shielding or screening effect, and the outer electrons are less strongly attracted to the nucleus as we go down a group. Furthermore, the atomic radius also increases, and this further decreases the force of attraction between the nucleus and the outer electrons. So both factors mean that as we go down a group, the outer electrons are less strongly attracted towards the nucleus.